Okay, let's try the next example here. Okay, for the increment. Okay, we want to find approximate of the change in z equal to fxy, and where fxy is x squared plus y squared multiplied with the exponent ex. Okay, so if the changes of xy is from 1 to 0.98 2.01. Okay, so now we can see here the increment. Okay, the increment of the increment of x, okay, which is 0.98 minus 1, okay, which is negative 0.02, and we can see the increment of y, which is from 2.01 minus 2, will obtain 0.01. Okay, so we have the formula, okay, which is, okay, let's say we take the z is equal to fxy here, okay, x squared plus y squared exy. Okay, so basically want to find the dz, which is the formula is fx, okay, dx, okay, plus fy dy. Okay, so now of course we want to find the fx and fy. Okay, so from here fx is given by, okay, so for this case we need to consider y as a constant. Alright, so okay, so this one is a product rule. Okay, so we can consider that. Okay, so we do it again. Okay, so fxy is equal to x squared plus y squared exy. Okay, so this is our u, this is our v, so our fx become uv prime plus vu prime. Okay, so we need to find the u, okay, v prime. Okay, so when u is equal to x squared plus y squared, so u prime become 2x. Okay, so when v is equal to exy, so v prime become v prime, this one with respect to x, right? So will be y exy. Okay, so this one is with respect to x. Okay, alright, so we just substituting. So x squared plus y squared, okay, v prime is y exy plus v is exy, u prime is 2x. Okay, so now, okay, what we can see here, okay, so exy we can factorize here, so the balance is, okay, y x squared plus y squared plus 2x, isn't it? Okay, alright, so now we want to find fy. Okay, so for fy still we need to use the product rule. Okay, so this time with respect to y, okay, so u is x squared plus y squared. Okay, so u prime become 2y, and v exy and v prime become x exy. Okay, so we just substitute in u, again the same thing, x squared plus y squared. Alright, v prime is x exy plus v is exy, and u prime is 2y. Okay, so we can simplify this one, exy. Okay, same thing. Okay, just the balance is x this time, yeah, x x squared plus y squared, alright, plus, okay, 2y. Okay, so it's not so clear here, it's 2y. Okay, sorry for my handwriting. Alright, so now we already have the fx, we already have the fy. Okay, so now we want to solve it. Okay, so we have dz is equal to fx. Okay, so now we need to substitute in. Okay, we need to substitute for fx12. Okay, so I try to do it first, yeah. So therefore fx 1, 2. Okay, so you just substitute. So it will be e1, 2. Okay, y is 2, 1 squared plus 2 squared plus 2, 1. Okay, alright, so if you use a calculator, you will obtain, what's this? Okay, and then you need to find it. And also for fy12, okay, you will obtain e1, 2 as well. So you will have x is 1, and then 1 squared plus 2 squared plus, okay, 2, y is 2. Okay, so you obtain this value. Okay, therefore your dz is equal to, okay, so you need to use your calculator to get the value of fx12 here. Okay, just calculate it first. Okay, alright, you will have it 2 squared plus 1 multiply with 2 plus 2 multiply with e2. Okay, hopefully my calculation is correct here. Okay, is it 88.6687? Okay, so hopefully we're correct. Okay, and then we will have 2 squared plus 1 plus, what is this, 4 multiply with exponent 2. Okay, so 66.5015. Okay, so now we just substitute into this formula just now. Okay, remember this is the formula, so we just use this formula. Okay, so 88.6687 multiply with dx. Okay, so our dx is negative 0.02 plus, okay, 66.5015 multiply with our dy, which is 0.01. Okay, so now 88.6687 multiply with 0.02. Okay, alright. Okay, so now we will have we need to plus with 66.5015 multiply with 0.01. Okay, so our answer is negative 1.10835. So 84 lah, we used for decimal places. Okay, so therefore the approximate change for the z here is negative 1.10